Hello humans. Today I decided my first video would be on how to explain to you the way in which probabilities are computed in quantum mechanics. It is a very easy subject for me, so I'll do it while I'm partially sleeping, if that's okay with you. So to make things even more simple, suppose that you're doing an experiment in quantum mechanics where there are only two potential outcomes, which you can think of true, false, or 0, 1. Okay, now these in quantum mechanics, potential outcomes of experiments are represented as vectors. So in this case, since there were only two outcomes, the vectors would be v0 and v called v0 and v1. And furthermore, you can assume that they are unit vectors which are perpendicular to one another. Now, what's interesting about quantum mechanics is that before making a measurement, your system can be a combination of these two vectors v0 and v1. In quantum mechanics, you call that a quantum superposition. So if you ever took linear algebra, this is what you would call a linear combination, and it's just saying that you can write v as a0 v0 plus a1 v1, where a0 and a1 are some undetermined numbers, whose meaning I'm going to shortly explain for you. So, as I was saying, this vector v is also a superposition of these other two vectors a0 v0 and a1 v1. Now, if you remember Pythagoras' theorem, the length of v squared, which would be the hypotenuse square, should be the sum of the squares of the two other lengths. So if you write it down, this boils down to saying that 1 should be the length squared of a0 v0 plus the length square of the vector a1 v1. So since v0 and v1 are unit vectors, that also tells you that 1 equals a0 squared plus a1 squared. And now here comes like the fun part, because if you call a0 squared p0 and a1 squared p1, you're getting that 1 equals p0 plus p1. So you just found two numbers which are non-negative and add up to 1. So in short, you can interpret those two numbers, p0 and p1, as the probability that when you make the measurement and your system started in the vector represented by v, it will be found with either in the state v0 or v1. So in a nutshell, to compute probabilities in quantum mechanics, you need to apply Pythagoras' theorem to the states that are written as quantum superpositions of the potential states that you can find upon measurement.